she has any questions. So let's make sure that we are recording. It didn't sit. Here we go. So just so you know, we are recording. Again, I'm Dr. P. So welcome to day 2. We are going to continue brushing up our Algebra 2 skills so that we are all prepared for pre-cal next year. So after the things that we discussed yesterday, I did pull up 2 other things that I thought were important and kind of, you know, relate to what we were doing yesterday that I thought, I want to make sure that you understand everything about it and there aren't any holes. I see a chat. I won't be able to talk. Okay. Oh my gosh. Okay. So, Christopher, how are you doing that at the same time? I understand. Don't worry about it. That is fine. I am recording the lessons and you should be able to access those lessons. Let's see. Let me just take attendance to make sure I know who is here and who is not here to make sure everything is set. So Ariana. Okay. So Reese. Oh, Reese, you made it. Yay. Abiella. Let me see. S2, that's you. Okay, so you're by a number. Abiella, turn on your camera, please. And then Eric is here. Cameras, please. Nathan, cameras, please. Christopher is doing double duty right now. Natalie is here, and I see Natalie. Ariana. Do we have Ariana? Yes, cameras on, please. And let's see, last but not least, Aurelia is who I am making the video for. Okay, all right, let me see your faces. I like to see faces. So let me pin you.
Can you see me now?
Let me see. Can I see you now? I see you. Yes, thank you. Okay. Let me just see everybody else's face. I need to have face. Nathan, there you are, Nathan. We're doing some graphing today for you, Nathan. And then Eric, let me see Eric. Hi, Eric. Okay, there we go. Okay, all right, well, let's get started. Okay, so let's talk about domain and range a little bit. This is so important. If you learn nothing else or master nothing else, domain and range is huge. So what I would like to do is I'd like to work through this. Let's just review some of the things that we talked about yesterday. So this is a nice description. It gives you examples. So yesterday we talked about relations, dependency relations, inputs, doing something to input values to get output values. And then when we talked about domain values, domain again, oops, my little pen is not, there we go. Domain is our input. So often X, but you know, other values can be input values. So domain is your input. And then range is your output. Oops. Values. And then we talked about continuous versus discrete. So if you can draw the entire graph, whatever it is, without lifting your pencil, it is continuous. So if we had a line or if we had a parabola, those are continuous graphs. But remember, we also had discrete graphs when we were given a set of ordered pairs or a specific table of values without a rule. Those were discrete. So we do kind of need to know the difference between continuous and discrete, and one of the practice sheets is going to focus on that as well. And then we talked about interval notation, and some of you expressed your unfamiliarity, can I talk this morning, on interval notation and how to read intervals and represent intervals with respect to domain and range. So remember, we can have open intervals. So if I have parentheses, that would represent open intervals, meaning those endpoints aren't included, or we can have a closed interval where the inputs are included. And I should also point out that we can have one side open and the other side closed. So you are allowed to have partially open, partially closed, depending on the interval that you are dealing with. So in the first example, you see, we do have a continuous graph because I can start at one point and that endpoint is included. So that is the way we are writing those. If the input is included with domain, we write it with a closed bracket. Now, notice this is written in as an inequality. So we should be able to recognize it as an inequality as well. So inequality versus interval notation, these are again two different representations. Let me just read this. Not a problem, not a problem. Okay. So let's look at the inequality, and then let's also talk about how to represent it as an interval. So as an inequality, we see that we're going 1, 2, 3, 4, 5, 6, -7. So if I'm reading from left to right, which is my domain, -7 was the least value. So we included that because it was a closed point. So we have -7, and then if we read the domain going to the right, we go up to 1, 2, 3, 4, 5. So then our largest domain value is 5. Since it is open, we put an open interval. Now, how would you represent that as an inequality? An inequality here, I didn't mean to erase that. An inequality, it would say that x can be any number greater than or equal to -7. So notice the or equal. That little or equal is how we represent this closed interval. And then x could be any number less than 5, but not equal to 5. So it's open. So do we see the relationship among the interval notation and the inequality notation? And again, this is for domain. Okay, can y'all see the screen? Yes?
Yeah, we can see the screen.
Okay, because someone is saying they can't see the screen.
If you Teams and then go back on, it should work.
Thank you. Sorry, I'm responding to people who can't see it. So let's see if they can see it. Okay, so again, we should be able to look at a graph, determine if it's continuous, and then also be able to represent the domain and range using both inequality and interval notation. Now, let's just review the range. The range represents our y values. So when we do the range, we're reading from the bottom of the graph. So this is the lowest point in the graph up to the highest point in the graph. So the lowest point is -3, right? So 1 to -3, and we go up to 1. So y can be any value in between and including -3 up to 1, but not including 1. So again, as an inequality, an extended inequality, this is how you would represent it. Y can be any number greater than -3 up to 1. And then as an interval, what would the interval be? How would I write that in interval notation?
Close bracket, -3, and 1 to 2, 1, parentheses. Sorry about that.
Excellent, excellent, absolutely excellent. So there you have an interval notation. So this is just a little review of the domain and range. And so what I would like you to do now, and there's more examples here, but I won't go over them unless you need them. I would like you to look at these sets. So here you have been given some information. You have been given the domain and the range as inequalities, extended inequalities or other sets. So what I would like you to do first is I would like you to represent the domain and range using interval notation, because we've got to be very comfortable going back and forth between the two notations. So let's do the first one together, and then you do the rest. And then once you have done that, I want you to look at these graphs, and I want you to match the graphs to the descriptions. And then we'll go over it. And if you have trouble, you can discuss it. I'll listen. I may chime in. So what would be the domain for the first one using interval notation?
Open bracket, -4, 4, close bracket.
Okay, why are you closing the right and keeping the left open?
No, closed.
Both closed. Excellent. You're perfect. Very good. Okay. What about the range? What would the range be it for interval notation? Anybody? What would the interval notation?
Bracket.
Say that
Open
again.
bracket. Open bracket, -4, 4, then close bracket.
Okay, again, why do you want to have an open bracket on the left?
Oh, I'm sorry. I meant the closed one.
You are correct. It is closed, right? Because that or equal to says that we are including it. If the or equal to isn't there, then it's open. Okay, so we are looking for a graph that has the domain left to right, our x values, -4 to 4, and our range, bottom to top of the graph, lowest y value to highest y value, -4 to 4, and it is not a function. So that means it doesn't pass the vertical line test. So we're doing the first one together. Do we see a graph whose domain is -4 to 4, whose range is -4 to 4, and it is not a function? In this first set of graphs, do we see a graph that satisfies those characterizations of the graph?
D.
D! Yes! We are going from -4 to 4 included, -4 to 4 included, and so heaven, no, I can draw lots of vertical lines and pass through it twice, so it's not a function. So we would go back and we'd say, all right, the first one is in fact D. So I want you to go through all of them. And let's go ahead, and if you want to find the graphs first, or if you want to represent the domain and range using interval notation first, I don't care how you do it, but let's go ahead and look at those and complete those, and then we will go over it. So I'm going to give you some time to work on that. If you have questions and you need to discuss it, by all means, let's discuss it. If you finish with this before others finish, there is a domain and range extra practice packet in your packet, so go ahead and start working on that. But I'm going to give you time to work on this. If you have questions, ask me. If you want to discuss things, ask me. But I'm giving you time to work. see. Oh, yay. Okay, good. I'm going to go ahead and write the interval form for some of these, just so that you can take a peek and make sure that you're on the right track. If you don't want to spoil the surprise, if you want to work first, don't look up. Well, actually, I'm going to ask y'all that. I don't want to give that away. Okay, if you wrote the interval forms for all of them first and you want to check them, you are welcome to check them. Notice the ones that only take on one value, I can't write as an inequality or an interval. Now, technically, for all real numbers, I could write negative infinity to infinity as well, if I wanted to specifically write it in interval form, right? Because it goes all the way to the left. It keeps going forever, right? How are we coming? Is it making sense? Yes? Are y'all doing the interval form first, or are you looking just for graphs first? Which are you doing first? What's easier for you?
The intervals.
You're doing the intervals first? I like that too, because that's quick and easy. I agree with you. Abiella, do you want to see the second page? Yes. Now, I intentionally left some blank because I want to talk about these a little bit more. How we would represent those as intervals. I'm going to ask you to tell me how to represent those as intervals. Eric, did you get them?
Yeah, I'm doing the interval notation first, and then I'm just like looking for the graph that matches it.
Okay, can you tell me what the interval notation for number 19 would be for the domain? How would I write that as interval?
Number 19.
Yeah.
Oh, I haven't gone to that one.
Oh, okay, all right. I'm not going to rush you. I'm not rushing you. I was just curious. Abiella, did you get number 19 in interval form?
I think
What did you get?
Close bracket 0 and then infinity for x.
Okay, well, x, it's saying that x can be any number that is less than or equal to.
Oh, shoot.
Less than or equal to. So what is the smallest value x could be? That's why I left that blank.
Oh my God.
That's okay. What do you think it is? Do you know?
No, I'm drawing a blank right now. I just feel really dumb.
No, don't. Okay, so it's saying that x, we're starting at 0, right? And that x can be any number that is less than or equal to. So if I go to the left and keep going forever and ever and ever, well, I know if I go to the right, I'm going to positive infinity. So if I'm going to the left forever and ever and ever, what do you think it might be? Does anybody know?
Negative infinity?
Negative infinity, yes. So negative infinity is all the way to the left. Infinity is all the way to the right. So the smallest value, you remember for an interval, you always write the smallest value first, and then the largest value second, and then whether it's open or closed. Now, with infinity, it's always open. So this would be negative infinity to 0 closed. Now, Abiela, what would the range be for number 19? If I'm reading this, it's saying y can be any number that is greater than or equal to. So if I look at 0 for my range, actually it ranges y, it can be 0 or anything greater. So if I go up and up and up and up and up, where am I going?
To infinity.
To infinity, right? So what's the smallest value for my range?
0.
0, and it includes 0, right? Because it's or equal to, and it goes to infinity. I left those two blank on purpose because I knew that they would maybe throw you off. Okay, Abiela, I'm putting you on the spot. Number 23. Number 23. Do we know how to represent the domain as an interval? X can, no, okay, can anybody tell me what the domain for number 23 would be as an interval?
Is it open bracket 5 infinity close parenthesis?
Okay, well, let's think about this. X can be any number that is less than or equal to 5. So if I look at my domain, it can be 5, but it could be any number that is less than. So where am I going if I'm going to the left, to the left, to the left, to the left forever?
So negative infinity 5.
Negative infinity. So negative infinity to 5, including 5. Well, does that make sense? Do we know the difference between that symbol and this symbol? If not, now is the time to say. This is greater than, if I can't spell, this is greater than, and this is less than. Kind of looks like a little L, right? So greater than means we're going to the right, less than means we're going to the left. Now, I like to look at this because it tells me which direction I'm pointing, right? Do you see that? And then if I'm dealing with the number line, this is positive infinity, this is negative infinity. This is positive infinity, this is negative infinity, if that helps. This is so, so, so important. This is so important. I like interval notation because it lets me see the left. I think got the X. Abiella, does that make sense? More sense? A little bit more sense now?
Yeah, it does.
Okay, good.
Oh, shoot.
Nate, is it making sense? I know you don't like working with graphs, but does the interval notation and the inequality notation make sense? Okay. Speak up if it doesn't. Ariana, is it making sense?
Yes, it
You,
is.
you see how we're going from inequalities to interval notation? You understand the infinity and the negative infinity? Okay, if not, speak up. Let me know if you're stuck. I mean, this is the time to make sure that we know this extremely well before next year. Or before it's a month away. I'll go back to the first page in case anybody wants to now check those again. When you have finished the matching activity, raise your hand in teams so I can see who's done and who isn't. I'm not rushing you. Okay, Reese, you've done it. Reese, go ahead and work on little machine that you are. Go ahead and work on this next thing. Okay. Once everyone's done, we will go over the answers to see if we get them. Anybody having any difficulty that they need help with? Feel free to ask questions if anything is unclear. Have we finished the first 12? Is anybody still working on the first 12? Because you're only using A through L for the first page. Is anybody still working on the first page? No? Everybody's done the first page? Okay. What is number 2? Which graph is number 2? Can anybody tell me?
G.
G, yes! Does anybody not see how it's G? Okay. Are we sure? So if I look at G, the only Y value is -1. Okay, good. What about number 3? Which graph is number 3?
H.
H, yes. Any questions on that? No? Nathan, number 4. Which graph is number 4?
F.
F, you are correct. Y'all are good, 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 good. What about number 5? Anybody?
A.
A, yes. If you don't get why one of these is the graph, we can review. I'm going to assume that you get it unless you tell me otherwise. Number 6, which graph is number 6?
C.
Excellent. What about number 7? E. Yeah. E. Number 8 describes which graph?
J.
J. Excellent. What about number 9? Oh, it is a function. It takes all real values, both domain and range. Number 9. Anybody get number 9?
L.
Which one?
L.
L. Is that what you said?
Mhm.
Yes. What about number 10? Reese, what'd you get for number 10?
Wait, B.
B, yes. Number 11, anybody? Anybody get number 11? Nobody? Abiella, did you get number 11?
K. Is it K?
It is K. Very good. And what about number 12?
Oh, okay, I.
I, you are correct. So we got all those. No questions on those. First 12. Okay. Wow, that's excellent. That is excellent. Are we still working on these? Do we need more time or are we ready to go over them?
I need a bit more time. I'm almost done with the second page.
You just keep on working. That's fantastic. Okay, Nathan, you're working. I love it. If you finish this one and you want to keep working ahead while others are working, there is in your packet a domain and range extra practice sheet. That is what we are going to do next. The domain and range extra packet sheet should be next in your packet. Okay, remember, once you have finished the last 12, go ahead and raise your hand so I know we can go over those answers. If you finish, feel free to move on to the domain and range extra practice sheet. I'm going to run to the restroom. I'll be right back. Just keep working. Eric, go ahead and move on to the domain and range. Okay, we still have a couple people working on it. Again, once you finish, raise your hand in Teams and move on to the domain and range extra practice. We're going to get that domain and range. We're going to get it. We're going to master it. If you happen to finish that, I did send a function notation practice sheet that I will display. I sent that in the Teams chat before class started when I sent the agenda for today. So if you want to open that and start looking at that and work that on a separate sheet of paper, that would be fantastic. Again, I know different people are working at different speeds, so I want to make sure everybody has something to work on. Natalie, we're doing okay?
I'm just a bit confused on some of these.
Well, why don't we discuss them if you're confused, Natalie? Like, what's causing you confusion? Vocalize the confusion.
I'm having a hard time like counting where each point is. Because
Okay.
I'm like getting confusing myself.
Okay, like give me an example. Like which graph are you looking at that's confusing?
Like the one number 16
Okay, number
versus
number 16 says it's going from -6 to 3 for the domain. So our x values go all the way to -6 on the left and 3 to the right, including both endpoints. So if I look, it stops at -6. So -6, well, that's not -6. That's not, well, 1, 2, 3, 4. Oh, that's not -6. 1, 2, 3, 4. That's not -6. That goes to -infinity. That's 0. Do you see how I'm reading these?
yes.
I'm looking for -6 all the way to the left. So that's not it. That's -infinity. It said it included the endpoint, so it can't be that one. That one's 0. 1, 2, 3, 4, 5, 6. Now that goes to -6 and it includes it, right? And how far to the right does it go for the domain? If I count, it goes as far right as what?
3.
3, and it includes it. Oh, isn't that what we said? -6 to 3. Okay, so it could be this one, but I have to check the range. So the range goes down to -5 and includes it and goes up to -1. So let's look. Does it go -5 to -1? How far down does it go? 1, 2, 3, 4, 5. That doesn't look like it's it, does it? Okay. So does this one go from, let's go back to the domain. 1, 2, 3, 4. That's not it, but look at this one. 1, 2, 3, 4, 5, 6. And it includes it. And how far to the right does it go?
Three.
It goes to 3 and includes it. Okay, so that domain works. Now let's go back and see what the range is supposed to be to see if it works. The range says what? The range says -5 to -1. So if I go back here, 1, 2, 3, 4, 5, that is -5. And how far up does it go? Oh, -1. So the range on this one is -5. So do you see why it's X?
Yes, I understand where I was going wrong.
Oh, well, okay. Well, share because maybe other people are doing the same thing. What was it that you were doing wrong? And if not, because that'll help me explain to other people who make that mistake.
Okay, I got confused to where I was like I wasn't counting the same way you were counting. I was looking for the exact point. So I was basically going, it was as if I was finding a single point. I was going like left to up and then down and all that. That's what I was doing wrong.
Okay. So yes, so domain, we're reading left to right. How far left does the graph go and how far right does it go? For range is how far down to how far up. Good. Okay, that makes sense. And this is a function because I can't draw a vertical line and pass through it more than once. Excellent. Good. Thank you, Natalie. And I know Christopher can't talk, so I'm not even going to ask him.
Miss, I'm having trouble understanding if a set is discrete or continuous.
Okay, so I'm going to verbally tell you, and then when we get to that sheet, I will go in more detail describing it. But continuous, so if we go back to actually how they described it here, if I'm looking at a continuous graph, that means I can draw the entire graph without lifting my pencil. And it's an interval, right? It covers an interval. So continuous means I have infinitely many points. So it's a line or a ray or a segment. So this is continuous. I can draw the whole graph without lifting my pencil. If I look at this graph, it is continuous because I can graph the entire thing without lifting my pencil. This is continuous. So that means my domain and range are potentially intervals. Now, if we go back to when I gave you things like a table of values or a set of ordered pairs where I said 0, 1, and 2, and I had 3 and 5 and 7. If I were to graph just those points, 0, 3, 1, 5, 2, 7, those are distinct points. I'm not connecting them. So to graph this, I would literally graph a point, lift my pencil. Graph a point, lift my pen. It's not continuous. So I could list my domain as the set of input values, but I don't have an interval. Does that make sense? So if it's distinct values, ordered pairs, or a table of values, or a list of values, it is discrete. These are all discrete because I can't draw the entire graph without lifting my pencil more than once, right? So those are discrete. Continuous means I can graph the entire thing in one continuous movement without lifting my pencil. And so that would be like a rule. And I don't know the equation for this. I'd have to get more information to write the equation. Make sense? Does that help, Eric? Okay.
Yes, ma'am. So what I misunderstood is I thought discrete was like let's say a function and it's limited to one area. And I
No.
thought continuous was that it had infinite points.
Right. No. Okay. So that's good. No, discrete. Discrete means it's just discrete, distinct little points. That's it.
Okay.
That's it.
All right. Thank you.
Yeah, of course. Okay. Are we ready to go over these last 12? Christopher, I know you can't talk, and I don't know if you're really, able to work at the pace we're working because you're multitasking. So I apologize if we're jumping the gun and you haven't finished. Number 13, which graph did that describe?
V.
V. 14.
Q.
Q. 15.
N.
N. 16.
X.
X. 17.
U.
U. 18.
O.
Oh, wow. Y'all are getting this. What about 19?
Miss, I didn't understand how O was for 18.
Okay, so love it. Let's look at 18. 18 says the domain goes from -4 to 7, including the endpoints. So let's go to O. O, -4, 1, 2, 3, 4. So it goes from -4, 1, 2, 3, 4, 5, 6, 7 to 7. So do you see why the domain is -4 to 7?
Yeah, it was just like at the bottom it hasn't the open thing.
Okay, so it wouldn't include that. So let's go ahead and count what the range would be. The range goes as far down as 1, 2, 3, 4, 5, 6, 7. And it's not included because it's open. But it goes as far up as what? Was that a -2? I can't really see. It's so tiny.
It's -2.
So do you see why it goes down to -7, but it's open because it's an open circle. So it doesn't really include that point. It goes to it, but it doesn't include it. And then it goes up to -2. So the range should be -7 to -2. Is that what it said? Yeah. Does that make sense? Makes more sense now? Excellent. Okay, what about number 19? Do we know what graph number 19 is?
P.
P, 20.
M.
M, 21.
R.
R, 22.
W.
W, 23.
S.
S, and 24.
T.
T.
Did this help with domain and range and interval notation a little bit? Okay, good. Excellent. If there are no questions, we're moving forward. So you should be working on the domain and range extra practice. So we're determining whether the information that has been given to you represents a discrete or continuous relation. You're determining if it's a function, explaining how you know, and then stating the domain and range as sets. And the sets can include intervals. So we're working on that. So I'll say here for the sets, that's a set. So it's a list or an interval. You can have an interval. Okay. So let's work on those. If you need to use the restroom or anything, you can take a little break, just to use the restroom, and then we'll just keep working. If you finish the domain and range extra practice, the function notation practice sheet is next, and that I attached in the chat for this team because I wanted to do a little bit more work with function notation. A little bit more work. So Eric, does that make sense? Like looking at 1, 2, 3, and 4, which of those is continuous and which is discrete?
Yes, ma'am. I'm still kind of confused about number 7.
Okay, number 7. I can jump to number 7 for you. So if I look at number 7 and I want to draw the graph to try to determine if it's discrete or continuous, I'm going to start at this point and I'm going to draw the graph. Can I draw the entire graph in one movement without lifting my pencil? Then it's continuous. However, so notice for continuous means that I have an interval. Continuous implies that I can represent the domain and range using interval notation. Discrete means I'm going to have to use a set, a list of values. Good question. Excellent question. When you have finished the domain and range extra practice, please raise your hand in teams so that I know that we can go over it. I'm not rushing anybody. I just want to make sure that, we go over things as you complete them. So when you finish the domain and range extra practice, please raise your hand in teams and then move on to the function notation practice sheet that I gave in our chat. So if I go to our team chat, function notation worksheet. And I'll project that just in case anyone is confused. So the one you would be working on next is function notation practice. I really like that sheet, that packet. It's really, really, really good. These are all really good. If you get stuck on anything or have any questions, please ask. Again, once you finish the domain and range extra practice, raise your hand so I know when we can go over it. And then move on to the function notation practice. I did a little bit of color coding. If you're stuck on any of them, I gave you a little color coding to help you with little hints. Ariana, Abiela, are you doing all right? Is it making sense? Any questions? We're good? Okay. Any questions, Ariana? Are we doing all right? We doing okay?
So once we're done with the domain and range, what do we move on to?
Move on to the function notation practice sheet. So I attached it in the chat of our team. So it looks like this. Let me open it. It looks like this. And you'll have to do that on a separate sheet of paper because I didn't include that in the packet because I realized while we were working that this would be good to do as well. So if you go to our chat team in Microsoft, in the chat before I started the meeting, I posted this. Can you see it? Okay.
Yes, ma'am.
Okay, let's go ahead and go over this page, these 2 pages, and then I'll give you time to work on those. So if you look at each of these, if you're not given a graph, if you're just given data, ordered pairs, table of values, it's automatically discrete. So if I look at these, I automatically know the first one is discrete, the second one is discrete, the third one is discrete, but is the fourth one discrete? Is number 4 discrete? No, it's continuous because I can draw the entire graph without lifting my pencil. So it is continuous. Now, if I move on to the next page, I look and see I have been given data, discrete, discrete. Is number 7 discrete or continuous? Number 7. It is continuous. That is right. I can draw the entire graph without lifting my pencil. What about number 8? Is discrete or continuous?
Discrete.
It is discrete. Yes, yes. Okay, so now that I've identified that information, it should be easier for us to recognize how I'm going to represent the domain and the range. If I'm dealing with a discrete graph or discrete data, let me write that in red, it's going to be a list or just a set. So my domain values, and remember, we write them in ascending order and we do not repeat. So my domain would just be the list of those numbers. The range would be the list of those output values. And remember, in ascending order, not repeating any values. Okay, same thing with number 2. Since it's discrete, I'm just writing the set, a list in ascending order, not repeating. Same thing with the range. I write it in ascending order, not repeating. For number 3, and stop me. If anything's confusing or you didn't get this, stop me. So domain for number 3, again, it is just discrete set of ordered pairs. So I write the ordered pairs. Well, I look at my domain values. I write them in order. I do this same thing with my range values. I write, oops, I forgot 4. I write them in order, not repeating any values. If you write a set out of order, not ascending, and you repeat the values, it is not a proper set. Okay, can somebody tell me what the domain for number 4 is? Domain for number 4.
Close bracket, -3, 2, open bracket.
Oh, beautiful. Beautiful. What about the range? The range for number 4.
Closed bracket, -5, 4, close bracket.
Excellent. Excellent. That's fantastic. Now let's go back and see, are these functions? Is the first one a function? And how do you know? How do you know?
Each
Output, input.
Each input goes to only one output. So I like to just look at these and say, are any of these repeating? If they're not, then there's nothing else to check. What about number 2? Is number 2 a function? No, specifically why? Where's the breakdown? Where does it go wrong?
0.4.
Yes, right there. Exactly. That 0.4 goes to due to two different output values. Excellent. Number 3, function, yes or no?
Yes.
Yes, it is. None of those x values repeat. Don't even have to check anything. Number 4, vertical line test. Is it a function?
Yeah.
Yes, it is. I cannot draw a vertical line and pass through the graph more than once. Excellent. Okay, let's look at the next one. Again, for domain, I'm just listing. Now, these aren't numerical values, so I'm doing alphabetical. Is it a function?
Yes.
Yes, it is. Each of these go to only one output. For the domain of the next one, again, I just list them. I'm going to list them in alphabetical order, but is it a function? Is number 6 a function?
Yes.
I'm sorry?
Yes, it is.
You think it is? Does anybody disagree?
I don't think it is.
Why do you not think it's a function?
Because A goes to Q and R.
That's absolutely correct. Ariana, do you see that? The fact that A,
Well, yeah,
that
it
goes,
looks like number 5 for a second.
aha, see, I tried to trick you there. So that you, Reese, you are correct. Ariana, I want be very careful. Make sure that each of those inputs goes to only one output. A goes to two different ones, forget it. Okay, what about number 7? Is it a function? Ariana, is number 7 a function?
Yes.
Yes, it is, because it passes the vertical line test, right? I can't draw a vertical line anywhere and pass through the graph more than once. But my question to you is, what is the domain? Ariana, can you tell me the domain? This is difficult. Domain.
-2, -1, and 1.
Okay, so it starts here, right? It goes as far back as -2. It's continuous and it goes up to 1, right? So those are the endpoints of our intervals. They're both included. Oops. So they're closed. Do you see that, Ariana? Does that make sense?
Yes.
Okay. Can we try the range then? Can you see how far down it goes and how far up it goes, and tell me the interval for the range? How far down does the graph go?
From -1 to 4.
-1 to 4. And what can you tell me about the endpoints? Are they included? Is it a closed parentheses bracket or is it an open parentheses?
Close.
It is closed because it includes those two endpoints. Excellent. Excellent. Number 8, it's discrete. So for my domain, I'm just going to list my x values. So I have -2, 1, and 2. And then for my range values, I have -3, 2, and 3. Do you see how I arrived at those lists as those sets for my domain and my range? Is there any, if there's a question, ask now. Do you see how I got the domain and the range? Okay. Is it a function?
No.
It is not a function. Why not?
it wouldn't pass the vertical line test.
That's right. If I were to draw a vertical line right there, it would pass through 2 points. So it doesn't pass the vertical line test. Excellent. 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 Any other questions on this sheet? No? Okay. Let's go ahead and move on. And let's work on the function notation. I will post it, or I'll display it. There we go. This is the one we're working on next. Here we go. Once you have finished this one, raise your hand so that I know you finished it, and move on to the next one. The next one being piecewise functions. And I also attached that one in the chat. So we're working on function notation. Once you have finished, raise your hand, please. If you are stuck, ask me questions. This one's a little tricky. I like it. You have been given 2 functions. What type of can you tell me what type of functions these are? You should know what type of functions those are. What type of functions are those? Anybody know what type of functions those are?
Slope and intercept.
I'm sorry? They are in slope intercept, so therefore they are linear, right? So both of these functions are linear. That's a line. That's a line. And how do we know by looking at the equation that well, you recognize sloped intercept form, but more particularly, the highest exponent of x is 1. So I know that these are lines. The graphs of these linear equations are lines. Okay, so you are trying to determine, did I give you the input or did I give you the output? If I gave you the input, evaluate the function at that input, give me the output. If I gave you the output, find the corresponding input value that yields that output. And then, of course, represent all your answers as ordered pairs. In number 2, you're just writing the information I have been given. You have been given information in function notation. So we are going from function notation to ordered pairs. You're just writing what I've given you as an ordered pair. And then you are trying to find an equation.
Hey, Miss, I have to go. Can I turn this in later on? Like send you a picture?
Well, actually, just watch the video and make sure it makes sense.
Okay.
Just make sure we'll watch the video. So just work on it. And then when you finish it, watch the video and then check your answers. If you have questions, ask me tomorrow. Eric, ask me tomorrow.
Okay, thank you.
Of course.
Also have a good day.
You too. These are harder. This is a more exciting worksheet. If you get stuck, ask me questions. I'm happy to work through something and help you along. Ariana, does it make sense?
I'm kind of confused on the C part.
The C part, okay. So in C, remember, this can be recognized as y equals 16, right? So I've given you the output. Here I've given you the x. I've given you the input. Here I've given you the x. So the input has been given, and you're just evaluating the function at that input. Here the output has been given, so you're going to set the equation. In this case, it's g of x. So you're going to set this equal to, and you're going to replace g of x with 16 and solve for x. Does that make sense?
Yes.
Okay, so here you've been given the A and B, you've been given the X, so you're just substituting in for X. In C and D, well, sorry, let me just say C. C, you've been given the output, so you solve for X. And then in D, you're given the input X. Natalie, we're good?
Yeah, I'm good.
Abiela, does it make sense?
Yeah, it's kind of making sense.
It's kind of making sense. Okay, let me know if you get stuck. Nathan, how we doing?
Number 3 is kind of weird.
Number 3. Oh, yes, because you got to think real hard about number 3. So on number 3, you are writing an equation, h of x. You're trying to find a rule so that if you were to input 1, the output would be 6. And if you input 4, the output would be -3. So what type of information have I given you? I've given you 2 ordered pairs, haven't I? Didn't I give you 2 points? 2 points? Okay, so I gave you, what's the first point? What's the first point I gave you?
1, 6.
Okay. And what is the second point I gave you?
4, -3.
Okay. Do we know how to write the equation of a line given 2 points? Yeah? You see, is it coming back to you? Uh-huh. Uh-huh. So what is the first thing you have to find to be able to write the equation?
Slope.
That's right. And what's the equation for finding slope?
y2 minus y1 over x2 minus x1.
Excellent. And it doesn't matter which one you're calling point 1 and point 2 as long as you keep them straight. Okay. And then once you know that, you can either substitute back into the slope formula or the point slope formula, which is an equivalent version. Excellent. Excellent. See, it's not so bad. It's not so bad. Reese, you finished the function notation practice sheet. If you want to move on to the piecewise function sheet, you can. I also posted that in our team chat.
Wait, which one? Sorry, it cut out.
I'm sorry?
It cut out. Can you repeat that, please?
Yeah, so after you finish this one, the function notation, go ahead and move on to the piecewise function sheet. And I attached that in the chat because it's not in your packet. So if you go to the chat where you got the last sheet, I've attached it there. So go ahead and work on that one as well.
Okay, thank you.
And let me know when you finish that one, because if everyone's still working on this one, you know, we'll see what we can do. So once you finish the function notation practice, raise your hand. Let me know if you get stuck on anything. Ask me questions. Any questions? Ariana, we good? Natalie? Abiella, we good? Any questions? We're doing okay? Raise your hand when you have finished the function notation practice. And if you finish, move on to piecewise functions. Natalie, Abiella, are we good?
I'm struggling a bit on number 2.
On number 2. Okay, so I have given you information in function notation, right? I've given you information in function notation. All I want you to do is represent the information I have given you as coordinate points. So as ordered pairs. In other words, what is the X value and what is the Y value? Can you tell? So there's no work to be done other than just telling me what's the input and what's the output. Don't make it harder than it is. Abiella, are we good? We doing okay? We confused?
Yeah, I'm just working on the fourth one.
Okay, on the fourth one.
Miss, I don't understand what's going on in the fourth one.
Okay, in number 4, you have been given a continuous graph. So I have a continuous graph. Now, you are being asked to find the output. So for example, here I have given you x equals -4. So if I look at the graph, when x equals -4, when x equals -4, what is the output? So if you're looking at it, if I say, okay, when x equals -4, right, because I've given you the x, when x equals -4, go to the point on the graph and tell me what the y value is. What is the y value?
2.
2. So the answer is just 2. So when x is -4, the function evaluated at -4 gives me 2. So the point -4, 2 is on the graph, right? What is the x value that I've given you in the next one, in B? What is the x? Do we know?
0.
0. So when x is 0, what is y? Zero. Good. Now in E and F, I've given you the y, so you have to find me the x. When you finish the function notation packet, raise your hand so I know we can go over. Any other questions, Abiela? Abiela, do you have any questions? Or are we good? It's making sense?
Yeah, I just work really slow.
That is okay. I don't care how long it takes you to get it. I just want you to get it. It is okay. For those of you working on the piecewise function sheet, do you have any questions on it? Anything unclear? Do you know what a piecewise function is? It's something that looks like number 3, 4, and 5, where different pieces of the graph are represented different ways. Okay. Let's go ahead and talk about the answers to this sheet. Okay, so let's go ahead and get this out. Let's go over this one, and then we can move on to the next one. So in this case, you have in number 1 been given either the input or the output. You have 2 functions. So you have 2 linear functions, and depending on which function you've been given, you're going to either substitute in the input or the output. In this case, you have been given the input. So I'm going to take the function and I'm going to substitute in 10 everywhere I see an X. So if I substitute in 10 where I see an X, what is that going to give me? Well, that's going to give me negative 30 plus 1. So G of 10 equals negative 29. Does that make sense? Yes? So all I have to do next is represent my answer as an ordered pair. As an ordered pair, the input is 10, the output is negative 29. So this is function notation. This is an ordered pair. In the second one, I'm now taking the other function, and everywhere I see an X, I'm going to substitute in 7 because I'm evaluating this function when X is 7. So that's going to be 14 plus 9, which is 23. So the function J evaluated at 7 is 23. The corresponding ordered pair, the point on the graph on that line, is 723. Stop me if you have any questions. Okay, Now, in this one, you are taking this function, but in this case, you have been given the output. You have been told that g of x equals 16. So I'm going to come over here and I'm going to substitute in 16 for g of x, and then I'm going to solve for x. So I subtract 1 from each side, and then that would give me negative 3x equals 15. So what is x? Can you tell me? What is that? Negative 5. So g evaluated at negative 5 is 16. So the ordered pair would be negative 5, 16. Do you see how I've written this using function notation? And then as an ordered pair. Okay. Now, in the next one, you are taking the function j of x, and you're substituting in negative 3 for x. So that would give me negative 6 plus 9. So j, evaluated when x is negative 3, is 3. And the ordered pair would be negative 3, 3. Any questions on number 1? Make sense? Okay. If not, speak now or forever hold your peace. Okay. Moving on to number 2, all you had to do is take the information that you have been given in function notation and represent it as an ordered pair. So what would the ordered pair for A be? What's the ordered pair?
Negative 1, 1.
Beautiful. What's the ordered pair for B?
2, 7.
Excellent. That's it. Just getting you comfortable with representing function notation as ordered pairs. Now, in number 3, you are trying to find the equation of a line. So I need an equation of a line, y equals mx plus b, and then I'm calling the function h of x. Now, I have given you h evaluated at 1. So when x is 1, y is 6, so I get this ordered pair. And then I've given you another set of information that says when the input is 4, the output is negative 3. So I have 2 points. If I'm trying to write the equation of a line, all I need are 2 points. So I'm going to find the slope of the line passing through those 2 points. So I'm going to call this one point 1. And I'm going to call this one 0.2. It doesn't matter which one you're calling 0.1 and which one you're calling 0.2. But then I'm going to substitute into the slope formula, which is your difference, your change in your y's over your change in your x's. So y2 is negative 3, y1 is 6, x2 is 4, x1 is 1. So that's going to give me negative 9 over 3, which simplifies to negative 3. Did we get the slope? Are y'all able to get the slope? Ariana, yes? Yes, makes sense? Now, once I have that slope, I'm coming back into this equation. I'm trying to write the equation of the line. It has this slope. But how do I find B? Can anybody tell me how they found B? There's a couple of different ways we could do it. How did you find B? Right now I have this, right? So how am I going to find B so that I can write this equation in its entirety? Does anybody know?
I put in like the values that it gave me, so I did negative 3 because that's the slope.
Okay, and then what did you do?
Equals the negative 3, and then I plugged in the 4 for the x.
Okay, so you are telling me that you took that point right there and you took the x value 4 and substituted it in for x, and you substituted in -3 for y. Does everybody see how Reese did that? She said, I know an x and a y. I've been given 2 of them. Doesn't matter which one you use. So I've been given an x and a y. So I took this x and I substituted it in here. And then I took this y and I substituted it in there. Does everybody see how you can use the information that you've been given and substitute it into the equation, and now all I have to do is solve for b? Reese, that's perfect. Yes? Are we sure? Abiella, does that make sense? Nathan, does that make sense?
Yeah.
Okay, so then I have -3. Nathan, -12 plus b. Is that how you solve for b? Nathan?
I was a little off on that part.
Okay, did you do something different? Did you get the same value of b? Did you get b to equal 9?
I didn't.
Okay, do you see how we can do that though? Once you have the slope, you can
Yes, ma'am.
okay, and then take any of the point, either one of the points is going to give you the same b. Okay, so then my final equation would be y equal, or actually I said h of x, right? Didn't we say h of x? H of x equals -3x plus 9. That is the equation. If that doesn't make sense, please let me know. Okay. Again, I'm happy to discuss anything in as much detail as we need to. All right, here you've been given the graph in number 4, and you're just supposed to be able to investigate the graph and tell me the values that fall on the graph given the input or the output. So in A, you've been given x equal -4. When x equal -4, y is 2. So I have that point. When x is 0, y is 0. It passes through the origin. In letter C, I've been given x equal 2. So when x equal 2, what is y? When x -2. So I have the point 2, -2. Abiella, when x is -5, what is y?
0.
0. Nathan, find x when y equals 2. So where does y equal 2? When x equals what?
I got 4.
-4.
When at 4. -4?
Right? Y equals 2 when x is -4. Does that make sense? When x is -4, y is 2. You've been given the y. Yes? Okay. But there's also another point. We're going to have to fudge that one a little bit because it's not an integer value. So when x is, let's say, that's a -0.5 maybe or so, maybe a little bit less than that. So there's 2 points when y equals 2, right? The 2 points are -4, 2, and -0.5, 2. So you'd have to actually see everywhere that y equals 2? What about when y equals 0? Natalie, can you tell me what the x values are for when y equals 0?
No, miss, sorry, I didn't understand that one.
Okay, so here you've been given y equals 0, right? So where are the points when the y values are equal to 0? Well, when the y value is equal to 0, I'm on the x-axis, aren't I? Isn't any point on the x-axis have a y value of 0? Does that make sense? When y equals 0, I'm talking about x-intercepts. When y equals 0, I'm talking about x-intercepts. So here, y equals 0. Here, y equals 0. And that's what I'm asking you. I'm saying find x when y equals 0. So when y equals 0, the two values of x when y equals 0 are what?
-5 and 0.
Beautiful. So those points are -5, 0. These are your two intercepts, your two x-intercepts. Does that make more sense? Okay. Now, here, so you have to be able to read a graph and interpret what's happening graphically and using different notations. So now let's look at this application. It's saying swine flu is attacking Porkopolis. Here is the function that determines how many people have the swine flu when t is time in days. So t is time, and s of t is the number of people in thousands that have the swine flu. So if this is the linear, and it's never linear for disease, but we're going to go ahead and say that it is because that's the equation we've been given. So if I'm asking you to evaluate S at 4, with respect to this application, what am I asking you to find? What does S of 4 represent? Can anybody tell me?
Number of people that get the swine flu in 4 days.
That's exactly. So when t equals 4, we have the number of people in thousands who have the swine flu. So all I'm doing is I'm coming into this equation that I've been given, and I'm substituting in 4 for t. So that would be 36 minus 4, which is what? $32, right? So since this is a word problem, you answer in sentences. So the number of people who have swine flu after 4 days is how many?
32,000.
32,000. That's right, because it says number of people in thousands. So what does that mean? The number of people who have swine flu after 4 days. So what am I asking in C? If I'm asking find t when S of t equals 23, what does the 23 represent? If I'm solving for t, then what have I been given? What information have I been given here?
T.
Well, I haven't given you t. You're finding t, right?
Mm-hmm.
The 23 represents the number of people who have swine flu, right? So I'm taking the same formula And I'm saying that 23, and this is 1,000, remember? 23,000 people, 23 equals 19 minus 4. So I'm solving for t, right? So I'm finding the time in days when 23,000, right, people have swine flu. So all I'm doing is I'm taking this equation here now and solving for t. So can we solve this equation for t? Of course we can. We add 4 to each side. So we get 27 equals 9t. And then we divide, each side by 9. And so after how many days do 23,000 people have swine flu? 3. So that's 3 days. Now, can we graph that function? Nate, here we go. We have been given a linear function, right? We have been given this linear function. I can write it in terms of x if I want. How do we graph that? What do we graph first? If I'm trying to graph this line, where do we start? What's the easiest thing to start with? Do I know anything about this graph?
The y-intercept is -4.
That's right. I know this. I know the y value of the y-intercept is -4. So I can come down here to -4, and I know the graph passes through that point. Right? That's my y value of my y-intercept. That's my b. Natalie, does that make sense? Ariana?
Yes.
Nathan? Abiella? Do you see how I can plot this point from this equation? Now, what is the slope of this line?
9.
9. So from here, I'm going to go up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm going to rise 9, and then I'm going to run 1, because that's really 9 over 1, right? So slope is rise over run. So my slope is 9 over 1. So then I can connect the 2 points, and I have the graph of this line. Nathan, does that make sense? I mean, you don't like to graph, so you say. Does that make sense how we graph that line?
Yes, ma'am.
Okay. Any other questions on this page? No? Okay. Let's go ahead and talk about piecewise functions, and then we'll work on piecewise functions tomorrow. So let's look at a piecewise function. What is a piecewise function? A piecewise function is just a function. So I mean, it passes the vertical line test. It's a function whose domain, whose equation or equations are defined over different domains. So I can give you a piecewise function. So if I just give you y equals mx plus b, that's just one equation. If I give you a function that is defined maybe in 2 pieces or 3 pieces, I'm going to have to define the equation. So this would be like f of x equals something. And then I'd have to state the domain for which that piece is defined. And then I would have another function for which that domain is a separate domain. So what do I mean by that? Well, let's look at a baby example. And I'm going to be very explicit about this example so I can make it very easy. Okay. So I have this piece. That's one piece. I'm going to do that in green. And then I have another piece Okay, so that's one graph, but it's two separate pieces. So it's not continuous. I can't draw the entire graph, the blue part and the green part, without raising my pencil. So this is not continuous in this case. Okay? So if I want to define this function according to the two pieces, because I have two pieces, I have a blue one and I have a green one. Right? I have two pieces to the graph. So if I were to try to describe this piece, it's a horizontal line. Do I know the equation of that horizontal line? How would I write the equation of this piece right here? What would the equation of this line segment be? Does anybody know? How do we write the equation of a horizontal line?
Y equals -2.
Y equals -2. So this piece right here is y equal -2. Does everybody see how that little horizontal line has that equation? If not, speak up. Okay, so f of x, I'm going to write it in function notation. F of x equals -2. That's one piece. Y equals -2. But that is only true from -3 to -1. And including that. So I have to define my domain for which this is true. It is only true for x values between -3 and -1. So that is how I'm describing that blue piece. Any questions on that? Now, I need to go to the green piece. And I need to write the equation of that line segment. Now, this piece is only defined between what? It's only defined from 0 to 3. Do you see how it's only defined from 0 to 3? So that's how I'm defining the domain. But I have to write the equation of this. It is a line. And what is the slope of that green line? Well, I can go from here to here and go 1, up 1 over 1, up 1 over 1, up 1 over. Do you see how the slope of the line is 1? And what is the y value of the y-intercept? Anybody?
0.
0. So all I have to do is write y equals x. So now I have written this graph's piecewise function. It's two pieces. I've defined it with two different equations over different domains. So this is how I would write the piecewise function, this graph defined as two different pieces. Any questions on a piecewise function? Have y'all seen this before? Ariana, have you seen a piecewise function? Natalie, have you seen a piecewise function?
No, I've never seen it.
You've never seen a piecewise function. Nathan, have you seen a piecewise function?
I've heard the name.
Okay. What about you, Abiela, have you seen a piecewise function?
No, I can't say that I can, but I have.
Oh, okay. So we need to spend some quality time on piecewise functions. So maybe tomorrow we will, do we want to work through these examples together tomorrow then? Since you haven't seen this, okay. So we'll actually work through these. I'll explain these, but I may give you some other practice for you to see it because you need to know piecewise functions. That's important, okay? So we're gonna go ahead and stop there because y'all have worked really, really, really hard today. And I don't want you to run out of steam, but I want you to dream about piecewise functions, and then we will work through these. We'll start off by going through these tomorrow. Okay, so no homework unless you want to just go back and review what we've worked on so far. Okay, so y'all have a wonderful rest of your day, and I'll see you tomorrow at 9. Have a good rest of your day.
Thank you, Miss.
Bye,
Goodbye.
Miss. Have a good day.
Bye.